I'm going to give a brief lesson over how to solve equations with a letter in them. When equations have a letter in them, it is called a variable. Anytime there's a variable in the equation, it is sitting there for a number to be replaced with it so we can find the true answer to the problem. From here on out in algebra, whenever you're learning algebra equations, the variable x will always be used. Later on in high school, they'll add x, y, z. Every single time you see x, y, z, any kind of number, it's usually implying that there needs to be a number replaced with that letter. So we're going to go ahead and get started and jump right in to just show a little bit more of what I'm talking about. So we have a problem, 3x equals 15. Looks like this. You might be looking at it thinking, what? That doesn't make any sense. Well, we know that 3 does not equal 15. If it said 3 equals 15, this statement would not be true. But the x is telling us something else. It's saying, hey, a number needs to be right here. There needs to be a number to make this statement true. So that is called our variable. Okay, also with working with these equations, anything that you do to this side of the problem has to be done to this side of the problem. And it's usually inverse of what you think. So right here we can see that 3 is going to be multiplied by whatever number is going to be sitting here. It's not going to be added because there would be a plus sign in between if it was added. But since they are right beside each other, that implies that we're using multiplication. But to get this 3 away, we want it to be completely gone. You have to divide it off. The reason that I divide 3 off is because we can't multiply 3 to this side. The number would just get bigger and x still wouldn't make any sense. So I need to get rid of my 3. So we have to divide 3 off of here. Whenever you do that, 3 divided by 3 gives you 1. You do not ever have to write the 1. You can if you want, but it's not mandatory. So our new equation is going to be x equals 15. Well, remember that whatever we did to this side has to be done to this side. So we divided this 3 off. Well, now we have to divide 15 by 3. So this is our new equation. X equals 15 divided by 3. This is an improper fraction. Whenever you have an improper fraction, it can be solved. In our case right now, it's going to be solved to a whole number. So if you know your multiplication and division, you know that 15 divided by 3 equals 5. So what we're left is x equals 5. Now we need to plug it back into the very first equation that we started with. And we need to make sure that it's true. So 3 times 5 equals 15. And it will be written like this. 3 multiplied by 5 equals 15. Is that statement true? Yes. So x equals 5. Right there. Okay. Now we're going to move on to a little bit harder equation. We're going to do 5x plus 20 equals 50. So this one looks a little more complicated because we're adding in this extra step, but it's actually really, really super duper easy. So we wouldn't divide this one off because before this is a plus sign, so that means we're adding 20. Well, we want to get rid of this 20. The main goal is to get x all by itself. So to get rid of 20, we need to subtract it from this side, like this. Okay, so a positive 20 minus a 20 gives you 0. Well, that 20 can't just be canceled out. We have to do something else with it. We have to do it over to this side too. So if we subtract 20 from here, we have to subtract 20 from right here. So 50 minus 20 will equal 30. our new equation is 5x equals 30. And it looks like this. Now we're back to the problem like we had in number 1. So instead of adding or subtracting, we know that this is multiplication. But in order to reverse multiplication, we have to divide. So we're going to divide the 5 off of here. And then whatever we do to this side, we have to do to this side. So divide by 5 and divide by 5. 5 divided by 5 is going to cross out. It's an implied 1, but the x will just stay there. It's representing the 1. So we have x equals 30 divided by 5. 30 divided by 5 is also an improper fraction. And this one will result in another whole number. If you know your multiplication and division, you know that 30 divided by 5 gives you 6. So x equals 6 right here. Now we need to check ourselves just to make sure, because mistakes do happen. We need to plug this back in to right there. I'm going to erase since I don't have a bunch of room. So 5x plus 20 equals 50. And now we're going to put our 6 in. 5 times 6 plus 20 equals 50. So 5 times 6 is 30. 30 plus 20 equals 50. And I'll write that out. 30 plus 20 equals 50. And if you add 20 to 30, you do know that it equals 50. So x equaling 6 is correct. Now moving on to another one. We're going to use a little bit bigger numbers now. 10x plus 20 equals 100. Now a lot of students are scared of big numbers, but this one's really easy. Whenever you have 10s and 20s, 100s, it's all divisible. It's going to be super duper easy. You're going to get a whole number. So the first thing that we do, again, is we have to subtract this 20 off and then subtract it off over here again. And this is called canceling it out. We're just trying to get this x all by itself. We don't want anything over here with the x if it's possible. So the 20 is gone from the left side of the equation. Now we subtract 20 from 100 and we get 80. And our new equation is 10x equals 80. And it looks like this. So this looks like the first problem that we did again. We have to divide. So we're dividing this side by 10, and then we're dividing this side by 10. We'll take it one step at a time. 10 divided by 10 is going to give us a 1x, and then 80 over 10. So x equals 80 over 10. Again, this is an improper fraction, and it can reduce to a whole number. So 80 divided by 10 equals 8. So here's x equals 8. Now we need to plug this 8 in right here. So our new problem is going to be 10 times 8 plus 20 equals 100. And we need to check to make sure that's right. So 10 times 8 plus 20 equals 100. So 10 times 8 is 80 plus 20 . So does 80 plus 20 equal 100? Yes, it does. So we know that x equals 8. For the last problem, we're going to do 9x plus 9 equals 63. Now 9s are kind of weird numbers. Don't be scared of 9s, okay? Any number you shouldn't be scared of, but since these look kind of funny and we don't use them a lot, it tends to scare people. But we're going to do the same thing. So we need to subtract 9. We have to get x by itself. We need to get rid of this 9 over here. We need it to go to this side. So subtract 9. And then you have to subtract 9 to the 63. So 9x equals 63 minus 9 equals 54. So our new equation is 9x equals 54. Now this looks like our first problem, second problem, and third problem. By now you should know that we need to divide this 9 off. So we're going to divide 9. 9 divided by 9 gives you a 1x equals 54 over 9. Now some people might look at this and be like, oh, that doesn't reduce. Well, it does. It's an improper fraction and it does reduce. 9 goes into 54 an even amount of times. So 54 divided by 9 gives you 6. So x should equal 6. Now we're going to plug that in up here and check our answer. So we have 9x plus 9 equals 63. 9, now I need to plug in our 6 right here where this x was. 9 times 6 plus 9 equals 63. 9 times 6 is 54. 54 plus 9 equals 63. So it should look like this. 9 times 6, which is 54, plus 9 should give you 63. You can count on your fingers. 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. So we know that for sure x equals 6. And that is our brief lesson over solving equations with a letter. Thank you.